Okay, so I'm just going to work those problems for you, and hopefully that helps. And then there'll be some more examples of tangent tomorrow in a video, and then you'll have an assignment Friday that has you do some more, but it's really just sine, cosine, and tangent. So I don't think, and if I'm wrong on this, then we'll do more examples next week, but I don't think there's anything on the test they're going to take next Friday over 4.5 to 4.8 other than sine, cosine, and tangent. So anyway, so I'll work these to see if that helps. And then if it doesn't, let me know. All right, so number 15, when you found all of the info for that, you actually had all of it right except for one piece of information. I'm also going to go ahead and warn you that I'm using this writing tablet thing that I have at my house, and sometimes it works great and sometimes it doesn't. So my writing's going to be kind of funky and my graphing will probably be horrible. Okay, so you said that the amplitude, which is not really amplitude, is 1/3. The period for tangent is normally 180 or pi, and I think you had yours in radians. You could do radians or degrees, either one, because there's no radian or degree in here. But I'll stick with what you had. So you said pi. So I agree with that because there's like an understood 1 here. So your increments, you're going to go with pi over 4, because you do pi divided by 4. Your phase shift is the thing that you had wrong. And here we go with, I can't use this thing to write very well. So phase shift, you had pi, but all that we have behind the tangent is an x. So if like we called that a set of parentheses, then we would say x equals 0. And when you solve, you get 0. So your phase shift is just 0. So your vertical displacement is also 0, meaning that your midline, oh my goodness. I have to write slow and deliberate, sorry. All right, your midline is y equals 0. So your max, if we had a max, would be 0 plus 1/3. Your min would be 0 minus 1/3. So you had all of that right. The only thing you had wrong was the phase shift. So when you go to make your graph, here's my x-axis, which is extra straight. Let's see if I can make it a little better. All right, so we're going to start with 0. And then we need 1, 2, 3, 4 more. And so counting by pi over 4, that would be pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and 4 pi over 4, which is just pi. And so you've covered a whole pi, or 180. All right, so the y-axis goes through 0, and we need to go up to 1/3. This is going to take forever. Okay, up to 1/3. And down to negative 1/3. And then you have 0. All right, so for tangent, what you have to remember is when you're graphing tangent, you have 1, 2, 3, 4, 5 marks always. Tangent always has an asymptote that runs right through the middle mark. So that 3rd mark. All right, and then when you're just graphing one period of tangent, you're going to get one, like half of it that goes up and half of it that goes down. So you're always going to have these outside points at 0, or if you have a vertical displacement, wherever that midline moved to. Your next point is going to be at your high point, because they're normally at 1 and negative 1. But in this case, we've kind of like condensed it. And so those are going to be at 1/3 and negative 1/3. So we get the up part of the curve here, and we get the down part of the curve here. You can draw these extra little pieces saying that you know what's going to happen. I'm not going to take off points whether you do or you don't. Okay, so number What was the next one y'all had to do? Because I don't remember the assignment. Number 19. Yes, number 19. I'm almost positive. Hang on just a second. I'm going to double check that I'm doing the right problems. And when I'm on that other screen, it won't let me pause. The pause button just showed up, but we're already halfway through it now. So, all right. So today, 19, 27, and 35. Maybe I'll remember that. All right. So number 19, you have y equals negative 1/2 and then secant x. All right. So your amplitude, which again, we don't really have one, but it's 1/2 and it's reflected. All right, your period for secant is 360. And there's no number here, so it's going to stay 360. And I'm going to do this one in degrees. Your increments, we're going to take that 360 and split it into 4 equal pieces. So 360 divided by 4 is going to give us an increment or a count by of 90. Our phase shift is going to be 0 because there's nothing happening with the x. All right, vertical displacement is 0, which makes the midline y equal 0, the max 1/2, and the min negative 1/2. Okay, so here's my x-axis. We start with the 0. And we have 1, 2, 3, 4 more. We're counting by 90. Okay, pretend like those are all legible numbers. All right, so the y-axis goes through here, and we just need to go up to 1/2, down to negative 1/2. All right, so for your secant graph, remember that secant is the reciprocal of cosine, and cosine has a point at 0, 1. So secant also has a point at 0, 1, but for us, it's going to be 1/2. All right, so then we would have cosine is 0 at 90, so secant has an asymptote at 90. Cosine is negative 1 at 180, so for us it'd be negative 1/2. And then we have another asymptote at 270. And then we're positive 1 or 1/2 over here. So when we put our points, our first point is at our high mark. The middle point is at our low mark. And the last point is at our high mark. All right, but we are reflected. So those three are actually going to switch. We would normally be at the high, but we're going to be at the low for the first one. The middle one would normally be low, but it's going to flip to high. And this one would normally be high, but it's going to flip to low because we're reflected. So we normally would have a U that goes down here, but since we're reflected, our U goes up. And we would normally have U's going up here and here, but since we're reflected, we have U's going down. And you can draw the entire picture, or you can just draw that half of it. I don't really care. Technically, we're only graphing 0 to 360, so you don't have to draw this part, but if you do, I won't take off points or anything. All right, so it's a good thing I pulled this up because I honestly don't remember. 27 is the next one. All right, so next we have number 27. So we have y equals 3 cotangent, and then 2x. All right, so these are being multiplied, so it's like that's in parentheses. All right, so we have an amp, not really, but of 3. We have a period Again, since there's no plus or minus in these parentheses, we don't know whether degrees or radians, so you get to pick your poison. So I picked degrees. Cotangent normally has a period of 180. This says put 2 pictures in there, which means 1 picture would take up 90 degrees. For your increments, you're going to take that 90 and divide by 4. So what is that, 22.5? Your phase shift is still 0 because phase shift only happens if there's a plus or minus in the parentheses. So phase shift of 0. If you take 2x and equal to 0, you get 0 for x. You do not have a vertical displacement because there's no plus or minus outside of the parentheses. Nothing up here, nothing back here. So your midline is y equals 0. Your max is 3, and your min is -3. All right, so x-axis starts at 0. You need 1, 2, 3, 4 more marks, and you're counting about 22.5. Well, I don't want to squeeze in 22.5, so I'm going to say this is 22.5. Add another one, you're at 45. Add another one, you're at 67.5. Add another, and you're at 90. If you don't want to label all of them, I'm okay as long as you get every other one. Okay, so y-axis. I have not put arrows on any of the rest. I don't know why I put them on that one. All right, so cotangent. Cotangent has an asymptote at 0 and 180 normally, but we have shrunk it down to 90 degrees. So it's going to have asymptotes at 0 and 90. Cotangent always has asymptotes at the beginning and the end. All right, and then it's a decreasing function. It's always going to be 0 in the middle. So asymptotes on the ends is 0 in the middle. All right, and then you're going to have one of your other 2 points at your high and the other at your low. So since it's supposed to be a decreasing function, it's going to start high and end up low. Since this is positive, we're going to keep that like we normally would. So normally this point would be at 1, but we're stretching it up to 3. And this point would be at -1, but we're stretching it down to -3. And then you draw, this is tough. We're going to curve through here and then curve through here. All right. I really have a horrible memory because I don't remember what the next question is. It is 35. All right, so number 35, I assume is a cosecant. Nope, it's a secant. Did we do a cosecant? No, apparently I just gave you 2 secants. Okay. All right, so you have 2 secant, pretend like that dot's not there, x plus pi. All right, so we have an amp of 2. We have a period. Normally it'd be 2 pi because we have to use radians this time. And it's still going to be 2 pi because there's an understood 1 here. So your increments will be 2 pi over 4, which is pi over 2. Your phase shift, we finally actually have a phase shift because you can take this x plus pi and equal it to 0. And you get that x is equal to -pi. So your phase shift is -pi. Your vertical displacement is 0. Midline, I don't know why it won't write all those lines, is y equals 0. The max is 2. And the min is -2. All right, so x-axis. Let's see if I can make it something close to straight. All right, so our first mark is -pi. We need 1, 2, 3, 4 more. We're adding pi over 2. So -1 plus a half is -half. plus a half is 0, plus a half is a half, plus another half is 2 halves. So a whole. All right, y-axis. And we need to mark 2, -2, and 0. All right, that's -2. Okay, so for secant, what did we say for the asymptotes? We said that it starts high, then it has an asymptote. So asymptotes are the second and the fourth mark for secant. So you should have asymptotes running through here and asymptotes running through here. All right, it's a positive function, so we don't have to reflect anything. So your first one is at your high, your middle one is at your low, and your last one is at your high. We're going to make a U that points down, or not. See if I can get it to happen. A U that points down in the middle, and these guys on the outside are going to point up. All right, I hope that helps. If you have questions still, let me know. There'll be a couple more tangents in tomorrow's video. And then I don't think you're going to have to do secant and cosecant on a test.